middle school long division. It's probably been a couple of years since a lot of you have done this. So just the steps. 6 is what we're dividing by, so that's called our divisor. 484 is our dividend, or what we're dividing into. And what you do here is when you're dividing 6 into 484, you start with your divisor and divide it into, you start with the first digit. So how many times does 6 go into 4? Well, it won't go into 4, so you move over and use 2 digits. So how many times does 6 go into 48? So it goes into 48 8 times. So you write that above the 8. And then you multiply your divisor by your number on top. So 6 times 8 is 48. Write that underneath, and you're going to subtract. So 48 minus 48 is 0. And then you bring down the next digit. So I'm bringing down the 4. How many times does 6 go into 4? Well, it doesn't go into 4, so you put a 0. 6 times 0 is 0. And when you subtract again, you get a remainder of 4. So this is 80 remainder 4, where 80 is called the quotient. So your answer is the quotient, and the 4 is your remainder. So you'll basically have 4 parts. You can write this a couple different ways. You can write it just like I wrote it, as the 80 remainder 4. You can also write it as 80 with 4 over 6. So your remainder divided by the divisor. And that would reduce to 2/3, but I'm not concerned about that right now. What you need to do is make sure that if you check this, your divisor times the quotient plus the remainder should equal your dividend. So working backwards, we've got 6 times 80 is 480, plus the 4 is 484. So when you check, the divisor times the quotient plus the remainder will equal your dividend. So let's do one more old school long division. 4 won't go into 1, so move over. 4 will go into 12 3 times. 3 times 4 is 12. You're going to subtract, which is 0. Bring down the next digit. 4 will go into 6 1 time. So 1 times 4. Bring down below, and then you'll subtract. 6 minus 4 is 2. Bring down the next digit. So 4 into 24 is 6 times. 6 times 4 is 24. And again, you're going to subtract. I've got 0, and then I've got one more digit to bring down. So I'll bring the 2 down. 4 will not go into 2, so I put a 0 there. So 4 times 0 is 0, and you subtract and get a remainder of 2. So again, you can write it like that, or as 3,160 with 2 over 4. So we're going to use long division to divide polynomials. Let's talk about vocabulary. Our polynomial that we're dividing into is our dividend. Our d of x is our divisor, what we're dividing by. Our answer is our q of x, or our quotient. And then you're going to add the remainder. And this will actually be a little different. You're not going to write the remainder like this, or r with the remainder. On polynomials, you're going to add the remainder. So let's look at some long division of polynomials. Again, here we've got our dividend, and our divisor. Now there's a couple things you need to be careful of when you're dividing a polynomial. It needs to be in order from the highest degree to the lowest degree, which is, we're good here. We have an x squared, then an x, and then a constant term. So it's in descending order. You also need to make sure there's no degrees missing. And this is x squared, x, and then the constant. So we're good here. We'll deal with missing terms in a later example. So for now, we're good to go. We're going to have 2x squared minus 10x plus 12. And we're going to divide that by x plus 3. So what I want you to concentrate on is just this first x, the first term, and this first term. What do I multiply x by to get 2x squared? Or what is 2x squared divided by x? You can ask that either way. So I usually do, what do I multiply x by to get 2x squared? Well, that's going to be a 2x, because 2x times x will give me 2x squared. So I'm going to put that above my x term just to line it up so it's kind of in an organized order. And I'm going to, just like I did before, I'm going to multiply my divisor by what I divided by. So out to the side here, I'm going to have 2x times x plus 3. When I distribute that 2x, I get 2x squared plus 6x. And that's when I'm going to put it underneath, lined up, my dividend. And again, just like in long division, I'm going to subtract that. Now you need to be careful here because I'm subtracting the whole thing. So if I subtract, I'm basically multiplying through by a -1, which is going to change the signs of each term. So if you multiply through by the -1, it'll change each sign. So when you line this up, 2x squared minus 2x is going to give me 0x squared. The next term, negative 10x minus 6x, is going to give me negative 16x. And then I'm going to bring down the next term, so plus 12. Then I start the process over again. I'm looking at my x and my leading term here. What do I multiply x by to get negative 16x? So here I'm going to multiply by a negative 16. So negative 16 times x plus 3 is going to give me negative 16x minus 48. And I'm going to line that up under my division so I can subtract. And again, I'm going to subtract, which is going to change all my signs when I multiply through by that negative. So that'll make the first term cancel out. Now, if your first term doesn't cancel out, you pick the wrong thing or your sign is wrong. So that's always going to happen. That's what you're after here, is for your first term to zero out. And then I'm going to add the next two terms. So 12 plus 48 is going to give me 60. Now, I'm at the end, and I know that because there's nothing I can multiply x by to get 60. So when you get to the bottom and this is got more or another x that you can't multiply something by to get what's the remainder, that is your remainder. So here I've got a remainder of 60. Now on your homework, they want this, they could want this written in different ways. The traditional way is to write 2x minus 16 plus your remainder over the divisor. That's the traditional answer. But sometimes on your homework, you got to be careful. They just ask for the remainder and they just want 60. So if you've got a box and it has like, what's the quotient? The 2x minus 16 would be the quotient, and 60 would be the remainder. If they want the whole thing written out, you'd put it in this form, the 2x minus 16 plus 60 over x plus 1. So that's long division. Let's look at another example. Here, I've got 6x cubed minus 19x squared plus 16x, and I'm dividing that by x minus 2. And again, I'm in descending order, and I don't have any terms missing. I'm counting down from x cubed, x squared to x, and really there's a constant term would be plus 0 if you want to fill that in. You don't have to, but if it helps you line stuff up better, it should be all the way down to no x term. So if there's one missing, it's a plus 0. So I'm going to start over again. I'm going to say, what do I multiply x by to get 6x cubed? Well, that's going to be a positive 6x squared. So 6x squared times x minus 2 will give me that 6x cubed and then minus 12x squared. So I'm going to write that underneath. And then I'm going to subtract that, which is going to change all my signs when I distribute that negative. So the 6x cubed minus 6x cubed will cancel out and leave me with negative 7x squared. And you really, really want to be careful with your signs here, because if you mess up one part, it messes up the whole problem. So be very careful with, I've got a negative 19x squared plus a 12x squared is going to give me a negative 7x squared. And then I bring down the next term, which is a positive 16x. And then I'm going to repeat the process. What do I multiply x by to get negative 7x squared? That's going to be a negative 7x. Also notice how I'm lining this up. My x squared is over my x squared, and my x is over my x. So it just kind of helps you keep it in order and keep track of everything. So when I multiply by a negative 7x, that's going to give me my negative 7x squared plus 14x. So I'm going to line that up underneath that. And again, I'm going to subtract. And notice how I'm using different colors here. It really helps if you have a different color. So when you change that negative to a plus, you can see it when you go back to look at it. So here my first terms cancel out. And that leaves me with a positive 2x. And you don't have to, but you can bring down the 0. So everything lines up. Now what do I multiply x by to get 2x? That's just going to be a 2. So I've got 2 times x minus 2, which will give me 2x minus 4. So line that up. And then again, subtract. So go through and change your signs. My 2x's will cancel, and that will leave me with a remainder of 4. And again, I can't multiply x by anything to get 4, so I'm done. And 4 is my remainder. So you can write that a couple different ways. I'm going to leave it as 6x squared minus 7x plus 2 plus my remainder over the divisor. So that's the traditional way to write it. Now, again, the homework might just want the 4 in its own separate box, so just pay attention to that. If you know you did it right and it's marking it wrong, just try entering the 4 in the divisor box instead of the 4 over x minus 2. Okay, let's look at another example. We've got x squared plus 3x plus 5 divided by x plus 1. Again, we're in order, descending order. There's no missing terms. So we're going to have, what do I multiply x by to get x squared? It's going to be an x. And once you've practiced this enough, you know, I've been going out to the side and doing x times x plus 1. If you can do that in your head, you can just go ahead and write it underneath. I'm going to have x squared plus 1x. And then I'm going to subtract, which is going to change all the signs. So I want you to do it very carefully like I did the first two examples. But once you get practice at this, you can go ahead and just change the signs and kind of do a little bit of the multiplication in one step. Just be careful, don't make stupid mistakes because it will mess up your whole entire problem. So 3x minus 1x is 2x, and I'm going to bring down the 5. So what do I multiply x by to get 2x? Well, that's just going to be a positive 2. And then when I multiply by 2, I get 2x plus 2. And then I'm going to subtract, which will change my signs, and leave me with 5 minus 2, which is a remainder of 3. So my answer will be x plus 2 plus 3 over x plus 1. So that was a pretty easy example. This next one is a little more challenging. First of all, because it's not in order. So I need to put it in order. So my highest degree is the cubed. So I've got a negative x cubed plus a 6x squared because it's positive, minus 15x plus 10. So that's in descending order. There's no missing terms. And then I'm going to divide by x minus 5. So what do I multiply x by to get the negative x cubed? Is going to be just negative x squared. So that'll give me a negative x cubed plus 5x squared. And then I'm going to subtract, which will change my signs. My first term should cancel out. And then I have 6x squared minus 5x, so that'll be 1x squared. Bring down the next term. And then start the process again. X, what do I multiply x by to get x squared? Is just going to be a positive x. So I've got x squared minus 5x. And I'm going to subtract. My first two terms will cancel out. And that'll leave me with a negative 10x. Bring down the next term. And then what do I multiply x by to get negative 10x? Is just going to be a negative 10. So I've got negative 10x plus 50. And then we're going to subtract, which will leave us with a remainder of negative 40. So I'm going to have plus a negative 40 over x minus 5. Okay, let's look at two more examples. These are important because if you notice here, the dividend is in order, but you're missing an x squared term. So we're going to put a 0 placeholder in there. You don't want to just put an x squared in there because that's 1x squared, which is a value. But 0x squared is equal to 0, but it just holds its place. So when I rewrite this, I'm going to have 2x to the 4th plus x cubed plus 0x squared minus 7x plus 4. And then we're dividing by x squared plus 3x minus 2. So don't forget about the placeholders. Make sure it's in order. We're also doing something a little different because we're dividing by a quadratic, but it's still the same process. I look at just the first term of the divisor and the dividend. What do I multiply x squared by to get 2x to the fourth? And that's going to be a 2x squared. So I'm going to put that above my squared term. And out to the side, I've got 2x squared times my divisor. And that's what I'm going to line up underneath. So I'm going to have the 2x to the fourth minus 6x cubed minus 4x. So that's what I line up underneath. And again, I'm going to subtract, so that's going to change every sign. So when I do that, my first terms cancel out, which is what you want to happen, and then I add everything else. So I've got a x cubed plus 6x cubed will give me 7x cubed. Oh, I messed a sign up here, so I should have plus here. Let me go back real fast and change that. So this is kind of what I was talking about. It's really easy to miss a sign. I've had a x squared minus 3x, and it should be x squared plus 3x. So that's going to give me 2x to the fourth plus 6x cubed minus 4x squared. So I still have the 2x to the fourth, but I have a plus 6x cubed minus 4x squared. And then when you subtract, that 2x to the fourth will cancel out, but I'll have negative 5x cubed plus 4x squared. Then I'll bring down the next term and start over again. What do I multiply x squared by to get negative 5x cubed? And that's going to be a negative 5x. So I've got negative 5x times my divisor, and I'll make sure I get the sign right this time. So that's negative 5x cubed minus 15x squared plus 10x. Line that up underneath. And then when you subtract, change your signs. So I've got 19x squared minus 17x. And then I'm going to bring down the last term. So again, what do I multiply x squared by to get 19x squared? That's going to be a positive 19. So I've got 19 times x squared plus 3x minus 2. So that'll give me 19x squared plus 57x minus 38. So I've got 19x squared plus 57x minus 38, and subtract, which will change your signs. Your 19x squared will cancel out, and then that will leave you with negative 74x plus 42. Now I can't multiply x squared by anything to get an x, so that means this is my remainder, the negative 74x plus 42. So my final answer is 2x squared minus 5x plus 19 plus a negative 74x plus 42 over x squared plus 3x minus 2. That is your final answer. Okay, let's look at one last example. We've got an x cubed minus 1. So I just have an x cubed. I'm missing an x squared and an x term. So I'm going to put placeholders in there. I'm going to have a 0x squared and a 0x placeholders, and then I'm going to divide by x minus 1. So start over. How many times does x go into x cubed, or what do I multiply x by to get x cubed? That's going to be x squared. So x squared times x minus 1 will be x cubed minus 1 x squared. Subtract. First terms will cancel, and that'll leave me with a positive 1x squared. Bring down the next term. What do I multiply x by to get 1x squared, or just x squared? That will be just an x. So x times x minus 1 will give me the 1x squared minus 1x. I'm going to subtract. So these will cancel and leave me with 1x, or just x. And I'm going to bring down the 1, or the negative 1. And then what do you multiply x by to get x? Well, that's just going to be a positive 1. So 1 times your divisor will give you back your divisor, or x minus 1. And then when I subtract, it's going to go to 0. So here I don't have a remainder. So my answer is just the x squared plus x plus 1. So that evenly divides into that polynomial if it has no remainder. Okay, so that's a bunch of examples over long division. We have another method called synthetic division, but we'll cover that in the next video. So my best advice is just be very careful. Do the work out to the side as much as you need until you get practiced at this, and just watch your signs. And a different color to change the signs is a very good idea, because it lets you know that you actually changed that negative into a positive whenever necessary.